So in today's session, we'll continue from the previous chapter of sports nutrition, sports performance nutrition, from page number 533 onwards. Items to improve performance. So the first item is caffeine. So caffeine, as we all know, is a stimulant. Okay, it stimulates your central nervous system, and it can boost your endurance and performance by giving you that quick energy, awakeness, awareness. Okay, it can improve your endurance, but if it is taken without sugar, okay, and in form of black coffee or diet cokes, okay, but it can also have some serious side effects. Those who are very sensitive, it can give you nausea, tremors, headaches. Too much of caffeine is also a diuretic, okay. It can lead to dehydration as well, and it can decrease your performance as well. Okay, so that is about caffeine. Next is creatine. So it is naturally available in meat and fish. Okay, so and it is used by the athletes to enhance their collagen. Some studies have shown that it can increase your high intensity and intermittent exercise performance. Okay, in tennis players and all. It can improve your hydration at the cellular level. Okay, it can hold on. Creatine will help you to hold on to more water. Your cells to hold on to more water. Even in sprint performers in hot climate, if you are taking creatine, you will not get dehydrated quickly. If you add creatine into your glucose water, it can promote greater gains in terms of fat and bone-free mass. Okay, so for toning purpose, for increasing the weight, boosting the muscle growth. So these are the main functions of creatine, where in sports nutrition, why creatine is used. Usually for high intensity strength training exercises, people use creatine supplements as well. Next is HMB, hydroxymethyl butyrate. So that is a metabolite of leucine. Okay, it's an amino acid, and it is also naturally available in some fishes, citrus fruits. Okay, it has shown that HMB can suppress your muscle protein breakdown. So it will not allow the muscle that you have gained. It will not allow it to break down. It can also slightly help you with strength. Adverse effects are not known. Okay, just 1 gram 3 times a day is the dosage that is recommended. Then we have Ephedra. So it's a herbal form, usually from China. It is available. It is used in Chinese herbal medicine. But overdose of it it has led to death as well. So there are a lot of adverse effect uh, with ephedra. Okay, it's an ephedrine stimulant. It leads to high blood pressure, increased palpitations, heart rate, seizures, stroke, heart attack, sudden death. So these are associated with ephedra. Okay, it's not that safe to use ephedra. And many sports authorities has banned ephedra. If any athlete is seen using ephedra, they will be banned from performing. Then citrus aurantium. That citrus name itself tells you that it will be available in citrus fruits. Okay, so it's an orange as extract of orange fruit, and it can work very similarly to ephedra. Okay, the chemical structure of this is very similar to ephedra, but it's much more safer option. Okay, then you have chromium picolinate. It has not shown any benefit so far, but there is a lot of adverse effect associated with chromium picolinate: stomach upset and anemia, cognitive impairment, damage at your DNA level, nephritis, kidney damage. Okay, these are associated. L-carnitine, people use it for weight loss and all, but there is no significant change that studies have shown. Okay, but it can cause muscle weakness. L-tryptophan, again, we don't have studies to support the use of it, but it can give you pain, muscle pain, myalgia. Then you have dehydroepiandrosterone, DHEA, and androstenedione. Andro, in short, we call it as andro. So these chemicals, just by name itself, we can understand it is related to androgen and testosterone. Okay, so these are chemicals that can produce more testosterone in humans. Okay, so it is naturally available in yams. Yams is suran. We in Hindi we call it suran. Okay, that elephant yams and all. There are different forms of yam. Okay, these are roots and tubers. Okay, so it's naturally available in yams. So testosterone and all, we know that it can uh, lead to some enhanced performance. So that is what people take it for, to produce more testosterone in them, to help them to improve their ability in performance. But too much of dosage can cause liver damage. In females, it can lead to females having male features. Okay, risk of uterine cancer. In males, it can lead to males having feminine features, leading to prostate cancer. So too much, it is still a very tricky medication to have. Next, coming to energy metabolism and energy pathways, different ways how your body uses energy. Okay, so basically, we all know energy comes from this macronutrients, your proteins, carbohydrates, and fat. Okay, proteins are broken down into amino acid. Fats are broken down into fatty acids, carbohydrates are broken down into glucose, and they enter your different cycle within the cell. They enter within the cell, that is mitochondria. This is where energy is produced. Okay, so certain amino acids, certain fatty acids, along with glucose, the metabolites of your macronutrients are used up by the mitochondria to create a lot of acetyl-CoA cycle, citric acid cycle, TCA cycle. Okay, so there are different cycles that take place within your mitochondria to produce energy out of it. Okay, and mitochondria will release energy as well as acetyl-CoA. These two things are released by your mitochondria after using protein, carbohydrate, and fat metabolites. Okay, so there are different pathways of energy production. Energy is produced in your mitochondria, but remember that. But there are different pathways in which energy is produced. Okay. So immediately, if you want ATP that is already produced by the mitochondria, for few seconds, your cells will use it, will give you the ATP that is already produced. ATP means adenosine triphosphate. Okay. Certain countries have banned certain items. Okay. Ephedra, you can check. Ephedra is the one that is commonly banned in most of the countries. DHEA and andro in your training and all you can use, but if you're into a competition, certain competitions have different guidelines. Okay, Olympics may have slightly different guidelines as compared to Commonwealth and all. So based on the competition which you are enrolling in, they will send a standard list to the athletes what they're allowed to be on, and if the in the blood test if they are found to if- to there is some fraud or something, they will be banned from performance. Okay, so different countries have their own take on different sports supplements, but usually ephedra is something that is banned everywhere, and some performance enhancing drugs as well. Caffeine is allowed. Caffeine is allowed for everyone. Then at immediate level, you have the ATP CP creatine phosphate cycle. I'll explain that also. So this blue cycle which will give you immediate energy. Okay, if you are in shock, you have to run away. You saw a tiger in front of you. You want to run away. Okay, so in that kind of situation, ATP CP, here they have given PCR, which means creatine phosphate itself. Okay, it is called ATP CP as well. So immediate energy, if you require, it is from ATP CP cycle. Okay, for short term exercises, for example, strength training. Okay, cardios that you do, strength training that you do, that will give you short term energy. Okay, so through glycolysis, anaerobic glycolysis. Okay, for a few minutes, and then on long term energy like cycling, marathon, walking for more than 1 hour or 2 hours. Okay, slow. The pace is very slow. Okay, you are not exerting yourself a lot. So in that long term kind of a situation in which you require constant supply of energy from more than 3 minutes for 2 hours and all. Okay, in that case, oxidative system is used that use aerobic metabolism. Okay. So each one of this we will see in detail. First is your ATP-CP, okay? Adenosine triphosphate, creatine phosphate system of energy, okay? This is an aerobic pathway, which means oxygen is used here, okay? So you can see here adenosine triphosphate, when it enters the mitochondria, there is an enzyme called ATPase, okay, along with water and ATPase. When they react with adenosine triphosphate, they break down adenosine triphosphate, okay, into adenosine diphosphate. One phosphate ion is broken down, okay. So this phosphate ion is now free. It will go and join with creatine. Okay, creatine is also found in your system. Okay, and when you take creatine supplement, again you get more creatine to join with this free phosphate so that it gives you continuous supply of energy. Okay, so now adenosine triphosphate. Triphosphate had three phosphates. Okay, now it has broken down one bond, and now it is adenosine diphosphate, only two phosphates. One phosphate ion is free, and when this bond breaks, that's when energy is released. Okay, so this ATP to ADP conversion is important for energy production. One phosphate ion has to be released for energy production. So this phosphate ion will go out in the out of the cell. It will find creatine. It will combine with the creatine. Creatine phosphate will be formed. ADP is also out in the circulation. So creatine phosphate and ADP will combine together. Now phosphate, this free phosphate, creatine will give its phosphate to ADP. So from diphosphate, it became triphosphate. So ATP and creatine, it became ATP and creatine. Creatine is again sent back into the blood. So this circle goes on and on. Okay. So again, you can see an ATP is formed here. So this is the ATP-CP cycle. When ADP is formed, P and phosphate ion is also released. Okay, when they find creatine, this is the reaction that takes place to bring back the ATP. And again, it will go under the reaction. It will be broken down. Okay, phosphate will be released, energy will be released, ADP will be released. They will find creatine again. This cycle goes on and on. Okay. So is it clear, the ATP-CP cycle? Is it clear to all? The main thing, creatine should be present here and oxygen should be present. Okay. Oxygen and creatine should be present along with water. Water gives the oxygen. Okay. H2O means you have one oxygen molecule here. Okay. So in the presence of oxygen, this is taking place. So it is aerobic metabolism. Okay. Aerobic energy production. Now what happens in anaerobic in the absence of oxygen? Okay, so you get glucose from your food. Carbohydrates have been broken down into glucose. Glucose, once it enters the mitochondria, it becomes pyruvic acid. Okay, glucose becomes pyruvic acid. It will glucose will give 2 ATP. Okay, glucose will enter the mitochondria. 2 ATP will be produced with one glucose molecule will produce 2 ATP. Okay, ATP will be used for energy production. But what remains, okay, is pyruvic acid. Okay, after glucose is broken down to make ATP, what remains is pyruvic acid. So now, is oxygen present or not present will be the question. Okay, if oxygen is present, it will undergo Krebs cycle, oxidative phosphorylation. This is where phosphate will be added. Okay, and again ATP will be produced. That cycle will go on and on. But what if the oxygen is not present? You're not breathing properly, or you are not dehydrated. You do not have enough oxygen. Okay, you are continuously exercising. All the oxygen has been used up. Okay, and the muscle is waiting for more oxygen to come, but it has not come yet. But it has to give energy. Okay, so when no oxygen is present, this pyruvic acid, this is acidic in nature. Okay, it will when anything that is acidic in nature, it does not get access to oxygen, it will undergo fermentation. Okay, so when pyruvic acid undergoes fermentation in the absence of oxygen, that is when lactic acid is produced. Okay, in animals, that is, we humans are also animals. Okay, the body, how energy is produced in us is the same way how energy is produced in animals also at cellular level. Okay, so when there is no oxygen, lactic acid is produced in animals. But when we are not talking about animals, if you are talking about yeast or any vegetables or plants, okay, when they undergo fermentation, ethanol is produced. Okay, that fizz that comes out, ethanol is produced, that is alcohol. Okay, but in animals, lactic acid is produced. This lactic acid is what gives you that sore muscle. Okay, you go to gym for the first time, in that first 2 days, you do a lot of exercise and the entire body becomes sore. That is because of lactic acid that is getting accumulated, because your muscles have only limited storage of glycogen. Okay, glucose in the form of glycogen is stored in your body. Okay, so glycogen undergoes lysis, that is glycolysis. Okay, glucose is being used up for energy. Now there is no glucose. So what will happen? Glycogen which the muscle has stored, that will be used up. Okay, now so you have to break down glycogen. So that is glycolysis. That is why this pathway is called glycolysis. When the glycogen is broken down, more glucose is released. Okay, glucose will give 2 ATP. One glucose molecule will give 2 ATP. What remains back in that reaction is pyruvic acid. So pyruvic acid will see, do we have oxygen? Do we do not have oxygen? If oxygen is there, pyruvic acid will go into the Krebs cycle. It will get one phosphate. Okay, it will become ATP, ADP, and so on. Okay, but pyruvic acid, if it sees there is no oxygen, it has to undergo fermentation and become another form of acid, that is lactic acid, and that is stored in the muscles, and that is what makes you feel that soreness. Okay, so this is anaerobic respiration. Okay, is it clear to all? So now coming to you can in the textbook you can see different pathways: ATP, anaerobic, glycolysis, different pathways. How much energy you will get, they have given in one table on page number 537. You can see that. Okay. So suggested pre-exercise food. So eating before exercise is important so that your body does not become sore. Okay, because if you eat before your exercise, when you have pre-exercise food, you're ensuring that there is a deposit of carbohydrates that will continuously supply glucose, so that your body does not have to undergo glycolysis, and your body does not have to become sore later on. Okay, so that is why pre-exercise foods are important. So 1 hour or less before exercise, there is just 1 hour left for you to do your exercise, or you have to go into a competition. Okay, if you're an athlete, you are into a competition, just 1 hour is left. So have some juice, fruit juice, vegetable juice, okay, like orange, tomato, or have some fresh fruits like apple, watermelon, peaches, grapes, which are sweet, because you need more glucose. Okay, or you can have 1.5 cup of any sports drink. If you do not have fresh fruits with you, you can just have sports drink. 1.5 cup of sports drink, that is enough. Okay, don't have any hard food which is difficult to digest. When there is 2 to 3 hours left before competition, you can have some fresh fruit. Okay, fruit juices, some bread, bagels, okay, like pav and also, okay, some low fat yogurt, sports drink. You can have that. When 3 to 4 hours is left before the competition, you can have a good food. Okay, something very close to a meal: pasta, baked potatoes, some energy bar, cereal with milk, okay, toast with peanut butter, some lean meat with cheese, sports drinks. Okay, this a light meal you can have. Okay. So general advice that you give for athletes: foods that you have to avoid before exercise, which are very slow to digest and difficult to digest, avoid that, because they will remain in your stomach for a long time, and your stomach will use all the blood for digestion. Okay, if the blood is used for digestion, all the glucose and the energy will go in digesting it. How will your muscles get the energy to perform? Okay, that's why avoid heavy food before any competition. And because of that, when there is that energy mismatch, your muscles want energy, your stomach wants energy. That's when the muscles will, if it is not getting enough energy, it will lead to stomach aches. Donuts, anything fried, potato chips, candy bars, these things has to be avoided. When to eat? Exercising on full stomach is not ideal. Okay, because the food will remain in your stomach. Okay, it can cause some stomach upset while performing or while competing. You will vomit, it will cause nausea, you will not focus, you may lose the competition. Okay, so you just have to make sure you have enough energy, but not a stomach that is full of food. Okay, so even if you have eaten a meal, you have to allow it to fully digest before you start the event or start exercising. It really takes 1 to 4 hours. If you have had a good full meal, It takes 1 to 4 hours to digest completely, depending on what you have had. If you have had some salads or fruits, okay, something that is very sattvic and all, within 1 hour, 2 hours, it will be digested. But if you had some full cream pasta, okay, pasta with cheese and all, if these things you have had, biryani, rice, dal and all, okay, khichdis and all with some ghee, if these are the food that you have had, you have to give your stomach at least 3 to 4 hours to settle down. Then you can start exercising. So always experiment your workouts, food and workout before you go into a competition. Don't change your diet few weeks before your competition. Never do that. Okay? Don't try anything new when there are just few days left for your competition. Okay? Only eat what you know will help you. Healthy eating practices. You you can guide the athletes to start their day with at least 2 glasses of water. Never miss the breakfast. Okay, 50 to 60% of the calories should come from carbohydrates, preferably from complex carbohydrates and natural sugars. Starches and sugars should give you energy. They are good in fiber as well. Foods that are highly processed, refined, simple sugar, these things have to be avoided. Eat more fruits and vegetables. Eat more whole grain rice, bread, cereals. Consume more legumes. At least 1 cup of skimmed milk or low fat milk should be there. Other general tips: choose lean and protein rich food like soy, fish, skinless chicken, because skin has more fat. Okay. Boneless and skinless chicken, like if you're going for the chicken breast, chicken thighs, okay, just that without bone, without skin, that will give you more protein. Okay, if there is skin and bones attached, that will have more fat content. Okay, very lean meat, fat free or just 1% dairy products, that is also fine. Eat foods that are naturally low in fat, like whole grains, fruits, vegetables. Consume a fiber rich food like oats, peas, beans, anything that has bran, rice bran, wheat bran. Limit all processed food, cookies, crackers, donuts, potato chips, fries, and all. Animal products like egg yolks, cheese, whole milk, cream, fatty meats, okay, like pork and all has to be avoided. That also large portions of fatty meats has to be avoided. Look for food labels. What is the content of saturated fat? Whenever you're buying anything packaged, check for the ingredients. There you will find the list of tables that has saturated fat, unsaturated fat, polyunsaturated fat. If the saturated fat content is quite high, avoid that. Okay. And also, if you see hydrogenated foods that have hydrogenated fat, avoid that packages. Okay, that are bad fats. Liquid vegetable oil is good there, and also anything that does not have trans fatty acid. Okay, these are good. Always take some glucose drink or carbohydrate drink before your exercise. Take protein rich food after exercise. Carbohydrate before, protein after. Okay, because after you have exercised, your muscles and your body requires repair. Okay, so for that repair, protein is required. To do the exercise, you require energy. For that, carbohydrates is required. So carbohydrates before exercise, protein after exercise. So athletes also should take supplements for vitamin B12, D, iron, zinc, calcium, especially if they are vegetarian athletes. So that supports sports and performance nutrition. If you have any queries, you can mention in the chat box.